So today we're going to be looking at section 2-1, which is on inductive reasoning. So inductive reasoning is reasoning based on patterns that you observe. Let's go ahead and take a look at an example where we would use inductive reasoning. So one case where we might use inductive reasoning is if we are given the sequence of numbers 1, 4, 7, and 10, and then we're asked to figure out what the next two numbers are. So, using inductive reasoning, I would try to find a way to get from 1 to 4, from 4 to 7, from 7 to 10, and then using the information that I got from here, I would be able to figure out how to get from 10 to the next number, and then from that number to the number after that. So, using some basic math skills, I can figure out that to go from 1 to 4, I can just add 3. It turns out that I can also get from 4 to 7 by adding 3 as well. Same thing going from 7 to 10, I can just go ahead and add 3. So if I continue my pattern of adding 3, I go 10 plus 3, I get 13, and then continuing my pattern again, 13 plus 3 is going to give me 16, and so I have used inductive reasoning to continue this sequence of numbers. Okay, so let's take a closer look at our definition for inductive reasoning. The definition of inductive reasoning is reasoning based on patterns you observe. So there are actually a couple of steps that we use in particular when we use inductive reasoning. There are 3 steps. Let's go ahead and take a look at those. The first step that we use in inductive reasoning is to look at data. So, to look at our example before, when we were given this set of numbers, 1, 4, 7, and 10, that was our set of data. The second step in using inductive reasoning is to look for a pattern. So again, to look at our example from before, I noticed that to get from 1 to 4, I added 3. Also to get from 4 to 7, I added 3. And to get from 7 to 10, I added 3 as well. So I noticed a pattern of adding 3. The third and final step in using inductive reasoning is to form a conjecture. So, when we noticed our pattern in our example of adding 3 each time, our conjecture was that to move from one number to the next, we added 3, and that is how we continued our pattern. So, let's go ahead and take a closer look in that word that was in the final step of inductive reasoning. That word was conjecture. Now, the formal definition for conjecture is a conclusion you reach from inductive reasoning. Now, I don't know about you, but this definition doesn't shed a whole lot of light on this word, so I also like to call a conjecture an educated guess. So what I mean by that is we can't be completely sure, but we have observed enough data and we've drawn enough conclusions that we're pretty sure that we're right, and so it is educated, but it is in fact still a guess. And because it is a guess, we do have to be careful sometimes. So now would be a good time to look at some of these patterns on our own. Let's go ahead and solve some problems. Okay, so for our first problem, I would like you to find what are the next two terms in the following sequence. So the sequence I'm going to give you is 3, 9, 27, 81, and I would like you to find the next two terms. So, remember the strategy that we use to solve these things, our inductive reasoning, is that we want to figure out what our data is, and then we would like to search for a pattern, and then after we found our pattern, we want to go ahead and make a conjecture. So go ahead and pause the video now and work out what the next two numbers would in this sequence would be using our 3 steps. Okay, so now that you've worked on it on your own, let's go ahead and look at this together. So our first step, the data that we are given, is actually these four numbers here. So for our data, we're going to have the numbers 3, 9, 27, and 81. Now, I do need to try to recognize a pattern. So I need to try to figure out how it is that I go from 3 to 9, from 9 to 27, from 27 to 81, so that I can then figure out how I find my following two terms. Well, I notice that if I multiply 3 times 3, I get 9. Also, if I multiply 9 times 3, I get 27. Awesome, we're on a roll. And if I multiply 27 by 3, I do in fact get 81. So the pattern that I'm noticing here is that I multiply by 3 each time. So then I'll use that pattern that I found to go ahead and make a conjecture as to what my next two numbers will be. I'm assuming that I'm multiplying by 3 each time. So if I were to multiply by 3 each time, then 81 times 3 is going to give me 243. And then if I multiply 243 by 3, that's going to give me the nice and big number of 729. So my conjecture is that my next two numbers are going to be 243 and 729. Okay, so let's go ahead and take a look at one more sequence problem, because not all sequences are going to be made up of numbers. So, if I gave you the following sequence where these are the first three terms, so this being term number 1, this being term number 2, and this being term number 3, go ahead and use our steps for inductive reasoning, which were to examine data, look for a pattern, and then form a conjecture. Use those 3 steps to figure out what the next 2 terms in this sequence would be. So go ahead and pause the video at this time and figure out what our next 2 terms are. Alright, so now that you've had a chance to work on this problem on your own, let's go over it. So my first step is to examine my data. So my data is these 3 figures here, and I need to figure out what the following 2 terms in this sequence, so what the next 2 figures in this sequence would be. I'm going to try to look for a pattern. So if I'm looking for a pattern here, I start out with one rectangle with nothing in it, but then on my second term I have added in this rectangle inside. And as I'm looking at this rectangle, I notice that these points here hit at about halfway, about the midpoint, to use a geometry term, on the sides of our original rectangle. Okay, so moving on to our third term, if I'm examining what we've added here, which is this guy in here, I notice that its corners are also hitting about the midpoint on the second rectangle that we added in step 2. So, if I'm going to continue this pattern, I will go ahead and form the conjecture that if this was my step 3, then my fourth term is going to be to hit the midpoints of this square, so the midpoints of this square, and I'm going to draw in another rectangle. Okay, so then trying to find my fifth term, this being my fourth term here, I'm going to continue with my conjecture that I need to hit the midpoints of my rectangle. So I'll go ahead and draw in another rectangle at the midpoints of this rectangle. So there I have it, my fifth term in the sequence, and I discovered it using inductive reasoning.